So here is the second unusual question in the P3 differentiation. It's coming from May June 10 paper 3 variant 1, and this is the first part of the ninth question, which according to me was slightly unusual as compared to other differentiation questions. If you remember from the previous video, I had mentioned that the differentiation itself was easy, but the trigonometric manipulations after that were a bit tricky for some students. Just like that. Over here also, differentiating this would be very easy, but the manipulations with respect to algebra, or I should say the power of indices, that might be a bit tricky for some students. But here we are going to look into this question. But by now, I hope you have understood the power of mastering trigonometric, algebraic, logarithmic, and exponential manipulations to do well in differentiation. And guess what? This is not just limited to differentiation. In integration, you will see this. In differential equations, you will see this. All of these manipulations are key factors for you to get a very good grade in P3. So I just hope that you keep on practicing this kind of topicals and you get better at it. And here comes this question where we are given the equation of the curve, which is square root of 1 minus x over 1 plus x. It's a u by v format. I can take a derivative of this. Okay, yeah, I first need to differentiate this. Okay, even if they did not give me this thing, I know how to differentiate this with the help of chain rule. That is, let's say this is some kind of a u. So I know that I can do half u to the power of minus half and then the derivative of u. This is what we have learned in the chain rule. That is what we can apply directly, even if they did not give this thing. But yeah, over here we can take this as a hint. Let us first differentiate it and finally obtain the derivative with respect to x for the curve. And then we have to show that the gradient of the normal at some point xy is equal to this. So it's the gradient of the normal. So first by doing the differentiation, we will just get a gradient and then we'll just do minus 1 over m, the negative reciprocal, to get the gradient of the normal. And that should simplify to this particular thing. Let's see how it turns out. Let's get started. Y is equal to, let me not call it a y, let me just call d by dx of 1 minus x over 1 plus x. I am going to apply the quotient rule, that is u dash v minus v dash u over v square. This is the formula that I'm going to apply to differentiate u over v. So let's get started. If I differentiate this, it will be minus 1. Then I'll keep v as it is. Then minus, differentiation of this is 1 multiplied with the u as it is. And then I need to divide this by the square of the denominator. So that is my differentiation over here. Once I'm done differentiating this, I need to differentiate the curve. So over here, dy dx is what I need to find. And for that, I know that this is same as writing 1 minus x over 1 plus x to the power of half. Square root is nothing but power of half. If I take the derivative, it will become half times 1 minus x over 1 plus x to the power of minus half. And then the derivative of inside, which is what you got over here, which I can simplify over here. It will be minus 1 plus minus 1 minus x minus 1 plus x, which means minus 2 over 1 plus x the whole square. This is the final simplification of this derivation. So I'm just going to multiply it with the derivative of this inside in the simplified format. 1 plus x the whole square, and we are done. Now we need to do the negative reciprocal of this and prove that this is equal to the given thing. And this is where it's a bit challenging in the entire question. So what I can do is, first of all, I can get rid of this 2 and 2. And then if I do the negative reciprocal, if I'm going to do the negative reciprocal, gradient of normal will be equal to minus dx dy, right? You're taking the negative reciprocal of this. So in that case, it's going to, first of all, this minus and this minus will get cancelled out. And this will become positive and this will go in the numerator. So it will be something like this. 1 minus x over 1 plus x to the power of positive half, because we have taken the reciprocal, and this will go on the top, 1 plus x the whole square. Now we have to simplify this and get it into this format. So let us try to understand what is given to us. We want 1 plus x, then square root of 1 minus x square. Okay, so it means that I have a square root of 1 minus x over here. Now I can go ahead and convert this into the power of, like, and I can write 2 as a power of 1 by 2 plus 3 by 2. Okay, so that it becomes 2. If you do this in the calci, 1 plus 3 is 4, 4 by 2 is 2. So I can write this 1 plus x square as this, so that I get a power of half on both the brackets. And then I can multiply my 1 plus x and 1 minus x directly. And then it's in the format of 1 plus x, 1 minus x, which is same as writing 1 minus x square. And that is what we are having over here. And then there is also a square root on top of that. So yeah, that thing will be satisfied over here. So let us first do this much and then think about how we can proceed ahead after this. So I'll just say that therefore gradient of normal will be equal to 1 minus x, 1 plus x, both are having a power of half, and then over here this is having a power of 3 by 2, and this is whole divided by 1 plus x to the power of half. Now because this is 1 plus x, this is 1 plus x, what I can do is I can take the power over here on the top. This half can go on the top and become minus half, and 3 by 2 minus half is equals to 2 by 2, which is equal to 1. So I also got this 1 plus x. So we are almost done, I guess. I'll just get rid of these things very quickly and try to simplify it now in one step. This will come out as, this is what a plus b, a minus b format. So this is 1 minus x squared to the power of half. And this is just simplified as 1 plus x. There is no power because 3 by 2 minus 1 by 2 is equal to 1. So this is our final answer, that gradient of normal, as we wanted, 1 plus x times square root of 1 minus x square. So yeah, you can see that the algebraic part, playing with the powers, was a bit challenging, but eventually we got to the final answer, as you can see over here.